Hi everyone, I'm Yuan, and I'm here to presenting our work lens. Our work focuses on the news recommender system and focus on the textual attacks. We develop a structure to manipulate such attacks, and we further analyze how that influence such attacks. Sorry, I'm a bit nervous. First of all, why do we bring in textual attacks? We can say in the news recommender systems, it relies heavily on the textual data. For example, the authors and editors can publish their self-edited content. Here. And those content providers could be benefited from such higher rankings of their content, and some of them might have a goal to gain exposure, which not necessarily a higher quality of the content. For example, from the right of the picture, we can see how health news for the people's health of the coffee could be manipulated by the attackers or the content providers, and they have the goal to make the content ranks higher. Such attacks can be achieved by the large language models, which is a textual attack. They can rewrite the news to boost the rankings of the content. And the existing works falls into three different families. The first one is sharding attack, and such attacks typically needs to injecting fake users or fake interactions, and it would be beyond the content provider's control. And the second one, maybe we can use the large language models and prompt it to make our content be more engaging. However, it would often lack the effective guidance and still would be a failed attack. And the third group is to simulate popularity items. For example, mimic the textual features of trending items. However, in news recommender scenario, the trending topics change rapidly, and which means it would still fall in such an attack. This means we need to develop a structure to conduct such attack to evaluate the news recommender system's robustness. Okay, here is our methodology. Our methodology of lens have two main parts. The first part is exploration, and the second part is reflection. Let's dive in. For the exploration, we first use the rewriting to generate diverse rewritten news. And how to generate rewritten news? We draw insight from these two existing works and use that to like the writing styles, sentiments, and personas, and prompt the large language model to generate different rewrite of news. Then we conduct a filtering to evaluate the rewrite impact on the rankings. Specifically, we use the top K and the threshold to filter in such rewrites. We can filter in the successful rewrites and the failed rewrites. And then we collect such original text, successful rewrite, and the failed rewrites. Then we feed such data to the reflection part and employ a diffuse training to prioritize the such successful rewrites. And we use the LoRA and the adapter to train the large language model. Yeah, that's the overview of our model. Then this is how we evaluate the attack performance. We evaluate it on the MAND dataset, which is an English dataset from the Microsoft News. And we have two different groups of metrics, which is attack performance and the neutralness. And we evaluate the performance on three different news recommender systems. And we use GPT-4 for exploration, and use llama for reflection to fine-tune it to rewrite the news. This is the fourth research question. How does our lens perform compared to existing attack methods? We can see here, our lens outperforms all base lens in attacking news recommender systems, which demonstrate the effectiveness of our lens structure. And here is the neutralness metrics for our lens. We can say lens neutralness is competitive across all neutralness metrics. And unlike other strong baseline ATR2FT, our lens shows a lower perplexity than the original news, which means the users would be harder to aware the news is changed. And for the second research question, how does the diversity of news content affect the performance? The answer is yes. We can see the diverse rewrites can enhance the attack effectiveness, and if we collect all the diverse results of the attack, the overall successes are even higher than all this separately. And one more findings is the negative and the neutral rewrites can outperform the positive one, which we think is a special findings in news scenario that users would more likely to click those news have more negative or neutral one. And this is different from other scenarios like e-commerce, because for the e-commerce, the positive text is more likely to engaging users to click. And the third one is to test the transferability and the generalization of our model. We can say we fine-tuned the lens on different data from different models, and we test the performance on analysis neutral recommender systems. And we can say our lens demonstrate a cross-system generalization, and which means such vulnerabilities exist in different news recommenders, and it's a shared vulnerability, and we hope to other people can find this problem of the vulnerability. Okay, here is the conclusion. We have 3 key insights. We can say our lens can significantly boost the rankings while maintaining the neutralness, because we use language model to rewrite the content. And we expose typical textual vulnerabilities in news recommender systems, and the negative and the neutral rewrites are more likely to get a successful attack. And we demonstrate the generalization, showing a shared vulnerabilities across all different recommender systems. And for the future direction, we hope we can develop the robust defenses targeting such large language model specific textual patterns. Thank you. Any questions?
Thank you for the presentation. It's kind of scary and fascinating, so thank you.
Thank you.
When you say success, I didn't understand that. Was it some sort of you just give it to people and they just clicked on it and yeah, I didn't understand your definition of success. I know some of the more kind of NLP, perplexity, and those kind of things. I understand that, but the success part is, at the end, it's news people will click.
Yes.
Yeah, and this I didn't get.
Thank you for your question. In here, as what I called success, I mean, if the original news falls behind the top K, and then after the rewriting, it ranked higher into the top K, then we consider it as a success. And the specific K here I used was 50, top 50 to measure.
So it's mostly the re-ranking. The ranking
yes,
is, so ranking. It's likely to be more clicked.
Yes.
Okay, thank you.
Thank you. Thank you for
still scary.